Hi, I'm David Geelan. I've introduced myself in a little clip on the main site. If you haven't seen that, you may want to go and see that to just get a sense of who I am and what I do, and why you should trust me to take you on this little journey. I won't talk too much more about that, but the purpose of this little video is to just talk little bit about the structure of the course, what we're doing, why we're doing it, where we're going. I already mentioned in my introduction video the idea that there are two main things that you will need: some physics content knowledge to just go a little bit broader and deeper. So what we'll try and do is talk about it at the level of Year 12, but go a little bit deeper and talk about it at the first year uni level at least as well, so you're a little bit further along than the students. We'll try and keep the maths requirements manageable. We'll try not to use too much calculus, but if you do know some calculus, we'll mention it on the way through so that you have that sense of the tool that provides as well. So some content knowledge, and then understanding the curriculum, understanding the syllabus documents and so on. And we'll talk a little bit more about that this week as well. It's one of the first things that we're going to spend some time on. The overall structure of the course, program, set of modules, whatever term we want to use for it, is there's a diagnostic quiz that I hope you'll do first up. And that's really to give you a sense, and me a sense, of where you're up to on the kind of physics content knowledge that's required in junior secondary. So year 7 to 10, Australian curriculum science, what are the physics concepts that we're learning in there? And are you up to speed on those? And do you have the mathematical tools that you need for year 11 and 12, which is basically being very comfortable and confident with your algebra. So just checking that, and it's mainly for feedback for you. Then there are four modules each 4 weeks for the 16-week period. And at the end of each module, there's a quiz. It'll be 20 questions, it'll be online, multiple choice. So it shouldn't be too daunting. And it'll be open for the last week of the module. So week 4, 8, 12, 16, those quizzes will be open and you'll be able to check your own learning, basically. The modules might have slightly odd titles because they include, because we're trying to do those two things, some physics content and some syllabus knowledge. So some of them are a little bit mingled, but hopefully that will become clear as we go, and we'll be able to talk about what each of the bits that you need are. In terms of resources that will be helpful, having the physics syllabus handy is really helpful. It means that you understand what you're actually mandated and required by the government to do. And again, I'll talk about that in a little bit. So there's a way to get it on that slide that's in front of you. There is a link on the website as well. So it should be quite easy to get hold of that as a PDF. It's about 60 pages or 54 pages, but only about 37 of it's the actual syllabus. The rest is other kinds of resources. So even if you just print out the 37 plus pages 51 to 53, which is the depth of treatment guide, which is really quite helpful. Get hold of a physics textbook. I've mentioned New Century Senior Physics there. It's a Queensland book. It's a good quality book that teaches in context and addresses the concepts and has lots of great practice problems and so on. Well worth getting hold of. Or acquire whatever physics textbook your school uses. If they're teaching physics there, have a look at that. Or just look around and find out what is a useful year 11 and 12 physics textbook. Because it's basically a place to get additional information beyond what I give you, or to clarify things, or to get a slightly different perspective on teaching ideas and so on. So it's really handy to have a textbook that you actually can lug around. And your mileage may vary. I personally like a physical book rather than an electronic document for finding things, being able to quickly flick through, checking the index, that kind of stuff, but up to you. I will put all of the slides for the PowerPoints that I use in these little talks up on the site as well. They'll be accessible. There'll be some sets of questions that I'll go through with you and that you'll have available as well. And then there'll be some suggested questions that you should go through each week. Maybe 10 or so questions just for practice. And that's really important, as I'm going to talk about in a minute. In terms of assessment, I've kind of put it in the scare quotes because there's not really a grade in this course. And I'm kind of pleased about that because I want you to be thinking about your learning. What do I actually know? Am I confident? Am I ready to teach? Do I have the content? Do I know the syllabus? Do I know the curriculum and pedagogy? So there's no grades, but there is feedback. So there's information. So you've got the diagnostic quiz, you've got the 4 quizzes across the semester. And the other thing I'm going to ask you to do is explain a physics concept as clearly as you can in writing. You can either do that on the discussion board site itself, or you can do it on another site like Socratic.org, which is nice because it allows you to, say, answer a student's physics question from somewhere else in the world with a really clear explanation. And it's got some markup, so you can do square root signs and squares and sigmas and whatever else you might have to use that's really difficult to do just in Word or whatever. So that's a way that you can do that explanation task. So do your explanation, put it up on the website, and then go and look at somebody else's explanation and give them some feedback. So, hey, I really liked what you did there. That's clear. That's a little less clear, or did you remember to include the units there? What happened at this step? I'm not quite sure how you got from there to there. Here's a great resource that helps explain this concept, and so on. So you're actually supporting each other in your learning. So there's those things: diagnostic quiz, 4 quizzes, and an explanation, and a commentary on someone else's explanation. So those are the things that you need to complete if you want the certificate of completion for this program, which hopefully will be helpful to you. It can go in your professional experience or professional development, professional learning portfolio, and be evidence to a school, if you move school, for example, that you actually have had some preparation for teaching physics and are able to do so. If you want something a bit more than that and you want to get some university credit for it, you will have done 16 weeks times probably about 2 hours a week of contact with the university, plus hopefully another, at least a couple of hours, maybe more, working on things privately at home. And that's equivalent basically to a university course. So we'll give you credit for a university course, but to be able to do that, you need to do an assignment for us that's at that university level. There will be a task sheet and a criteria sheet for this task, but basically what it is, I've got the program of work, the 2-year program of work from a school that I know. I've de-identified it so that you can't find out which school. And your mission is to read over that and go, okay, as a newly trained, experienced, educated, knowledgeable physics teacher, I really love what they've done here. I learned a lot from what they did here. This bit I think is a bit weak. I would strengthen that, and here's how. This bit I think is maybe a bit over the top. They've spent too much time on something they should have done more quickly. So you're providing a critique and an improvement plan. What's great about it? What could be better about it? And what would you do if it was your work plan to make it better? So you're basically demonstrating everything you know, because that involves demonstrating your curriculum knowledge and your content knowledge. And it also is quite authentic in terms of preparing to go and teach physics. So hopefully that will work. Only people who actually want that university credit need to do that one. And they can spend the time to do that, and they'll get 1 course out of the 4 required in the Griffith Grad Cert in STEM education. So if you can pick up another 3 courses, you can do that part-time over time. Some of them will be online, some of them will, probably at least one for science people will be face-to-face, just so we can get you in a lab and having some experiences with labs. But that's an option that's there for you, and there'll be more information as we go through. There's no substitute for practice in learning physics. We know that if we learn something, we know it, then very quickly, if we don't do anything with it, it drops off. If we learn it again, it goes up to the same level and drops off less quickly. Learn it again, it drops off less quickly, and so on. If you want to retain something, address it multiple times, spend time practicing, do some work on it. So I would really recommend get lots of paper. There's no such thing as waste of paper in studying physics. Draw big diagrams, write things out in full, and do lots of it. Do lots of practice, because that's how it gets in your head. That's how you process it. It doesn't just go in that surface layer, it goes in deep and stays there. And then once you actually teach it, you really understand it. So you'll have the opportunity, hopefully, to do that fairly quickly. I will post problems, probably about 10 a week, when we're doing a physics concept-y week. There'll be kind of curriculum-y weeks where we won't post problem sets, but for physics-y weeks, we will do a problem set and leave them up for a week for you to have a go at, and then I'll post the solutions to make sure that you're confident that you know you're doing them correctly and so on. The discussion board is really quite an important part of your learning. It's one of the things that makes this course not just you and me and a computer, but a class, a collaborative learning activity where you learn from other people and they learn from you. So get in there, introduce yourself in the introductions thread, have a look at the resources thread where there's lots of shared resources. I've added a couple, hope a lot of other people will add a lot more, add some of your own. There's a thread for each module if there's something you don't understand or want a question. And we can add new threads or forums if there's an interest in something. If someone wants to discuss a particular topic, we can add more stuff. It's pretty flexible, and I've been teaching in these online environments since 1995, so I'm pretty comfortable playing around with the technology and making things happen that are interesting. I'll participate, I'll answer some questions and be involved, but I hope you'll also value the answers from your fellow participants. There's a lot of knowledge, a lot of experience, a lot of understanding in the room, the virtual room. So, I hope you won't just hang on my answers, but you'll listen to one another and get information from each other in the discussion room. That it will become a genuine discussion rather than a bulletin board where you post something like a lost dog or a car you want to sell, but that it's actually a conversation. And that's the kind of metaphor, I guess. The Collaborate discussion is another part of making it a class rather than individuals. Collaborate basically is an online discussion space where we can do audio, and I can have a whiteboard or write things up. I can answer questions and problems. The ideal way for you to do it is to have a microphone and earphones, because sometimes we get feedback problems if you're listening off speakers and have a microphone, or one of those headsets that has earphones and a microphone in it. That's probably the ideal technology, and those are pretty cheap and accessible these days. It means that we can all talk to each other verbally. We can also chat, typing if you don't have the audio working properly. I can show you video or a whole variety of other bits and pieces. What I'll do is I'll come along with some problems prepared, but I'll be very happy to jettison those and work on your questions if you bring questions along. It's like a tutorial. It's not another lecture. The lectures will all be on video like this, but the Collaborate session is a time to have a conversation and answer some questions, work through some problems and so on. And that's really about all I wanted to say. So I hope that has been a useful introduction, that it's clear, that you have a sense of where we're going and what we're trying to achieve. And I look forward to working with you over the next 16 weeks.